Machine learning and statistics are actually very closely related. Most of the statistical concepts and terms you'll typically use are actually used during the exploratory data analysis phase. That is, you analyze the data that you have collected and draw insights from it. During that part, you will be using a lot of these statistical concepts. Let's do a survey of some of the very basic statistical terms used in ML. And in that process, we will understand the intuition behind it and the core concept behind each of those statistical terms. Let's get started by understanding the different types of data that you will use when building machine learning models. That is, when you're collecting data, the types of data is primarily can be divided into qualitative data and quantitative data. When I say data, in a data set, I'm referring to structured data sets. In structured data sets, you will have different columns, and the data present in those columns is either qualitative or quantitative. In other words, the data is either categorical. Other word for qualitative is typically we call it as categorical data or numeric data. This can also be called as qualitative or quantitative. Now, when it comes to qualitative data, it's either the categorical variable can either be nominal variable or ordinal variable. We call a variable as nominal variable when there is no intrinsic ordering to it. For example, if the values of the variable is red, green, and blue, the values red may not be having any sort of relative ordering between green and blue. There is no intrinsic order to it. If that is the case, we call it as nominal variable. Whereas if there is an intrinsic order to it, for example, say you are giving product ratings and the ratings varies between 1, 2, 3, 4, 5. It can hold only 5 values, right? Even though these are numeric in nature, these are only limited 5 set of categories, right? 5 different values. So this can still be considered as a categorical variable and an ordinal categorical variable because there is an internal ordering to it. Good or bad. This is also ordinal. Good can be 1, bad can be 0. Pass, fail, malignant, benign. So there is a certain internal ordering to it. In that case, you can call it as ordinal variable. On the other hand, numeric variables are either discrete, for example, the number of items. There is no fractions or this cannot be a real number. It can be a discrete number, right? Or it can be continuous. If it's a real number, we call it as a continuous variable, right? Height, weight of the person, things like that. These are the general framework or general layout of the different types of data that is possible when building machine learning models or collecting the data for building machine learning models. Now, once you collect the data, you're going to be performing certain analysis on top of the data. We call that analysis either descriptive statistics or inferential statistics. What is the distinction or difference between the two? We call something as descriptive statistics when you are trying to sort of describe the data itself by computing certain statistical metrics. For example, we will cover these statistical metrics in more detail. These statistical metrics are divided or generally classified as either measures of central tendency or measures of dispersion. I will shortly in the next slide right after this, we will see what these measures are exactly one by one. All right. On the other hand, inferential statistics is when you try to make sense of the data by drawing some insights. You are focused on deriving insights out of your data. For example, in our housing prices data set, say this is your data set, right? You have various fields. Some of them are categorical, some of them are numeric. Say this is your price of the houses, and this is your location, area of the houses, something like that. These different columns are present in your data. By looking at the areas of the houses, you might come up with certain insight. For example, 90% of houses sold has area lesser than say XYZ square feet. This could be an insight. Likewise, there could be insights based on the locality of houses, based on the number of schools present around the houses. So various different variables present in your data can be used to generate the insights on its own. And whenever it is focused on generating insights, it's called inferential statistics. Now coming to the measures of central tendency, like these are the measures, central tendency and measures of dispersion. These are the measures used to describe the data. Now measures of central tendency, that is the mean, median, mode, geometric mean and harmonic mean. These are measures used to describe where the data is located. The location of the data itself can be described using these measures. Whereas measures of dispersion try to convey how the data is scattered across, how they vary from each other. For example, standard deviation, variance, coefficient of variation. So standard deviation basically tells you how the data is scattered. Variance is nothing but the square of standard deviation, right? And coefficient of variation is nothing but standard deviation divided by mean. That is nothing but coefficient of variation. Quantiles range. Range refers to the minimum and the maximum value of a given numeric variable. This is nothing but range, right? Another very nice pictorial way of describing the data is using a box plot. What you see here is a simple box plot. Now let's understand the components of this. A box plot here, the central portion of the box plot, this is the box itself, and these are the leaves of the box plot. All right. The box here, the starting point and this ending point of the box corresponds to 25th percentile and 75th percentile. The 25th percentile is also called as the first quartile, and 75th percentile is also called as third quartile. And the distance between 75th and 25th percentile is nothing but the interquartile range, IQR. This is a standard statistical term, right? First quartile, third quartile, and interquartile range. Now there's a certain distance between the end of this point, that is the third quartile, and the end of this leaf. Similarly, we also have a leaf over here. So this distance is nothing but this distance from this point to the end of the leaf is nothing but 1.5 times the IQR. Likewise, this distance is also 1.5 times IQR. The significance of this is any point that is lying outside this 1.5 into IQR is generally considered as an outlier. The points that lie outside these ranges is generally considered as an outlier. Outlier means generally it's an anomaly point. It's not a typical representative of the rest of the data of this particular variable itself. It's also sometimes called as extreme value points or simply as anomalies. So box plot is a very standard and a very useful representation of data.